The linear constant graph only has an a value. When you raise the a value, the y-intercept moves up the x-axis. When you reduce the a value, the y-intercept moves down the x-axis. Increasing the a value of a linear function increases the slope of the graph. Inversely, decreasing the a value of a linear function decreases the slope. When a becomes negative, the graph flips over the x-axis, resulting in a negative slope. Just like a, changing the b value increases the slope of the graph upon positive input value. Decreasing the value past 0 makes the slope negative, or flips it over the y-axis in this case. In reality, the net effect of increasing and decreasing the a and b value in a linear graph is the same, because there's no differentiation between x and y changes, given it's one line. When increasing the h value of a linear graph, the graph moves to the right on the x-axis. When decreasing the h value, it moves to the left of the x-axis. When increasing and decreasing the k value, the graph moves up and down the y-axis, respectively. For the quadratic function, if the value of a is greater than 1, it's a vertical stretch. If the value is less than 1, it's a vertical compression. If the value is negative, it flips over the x-axis. If the value of b is greater than 1, it's a horizontal compression. If it's between 1 and 0, or a fractional value, it's a horizontal stretch. If the value is negative, it flips over the y-axis. Since the graph is symmetrical, this doesn't reflect anything. If a or b is 0, it's just a straight line. If h is increased or decreased, the graph moves left and right on the x-axis, similar to the linear graph. If k is increased or decreased, the graph moves up and down on the y-axis.
Koni pale ka uluhia I ka halia o hiia ka I ka ua o ka ua noe noe o ka nile hua ho'opulu I ka puna mai a ke ali